So one of the first PLCs you guys are going to look at will be one of these Siemens logo. This is their entry-level PLC. Arguably it's a controllable relay. The outputs are slightly more limited than most normal PLCs. So down the bottom here we've got 4 switchable relays. So power is coming in. You can just make it out on the brown leads that are coming into the bottom here. That's supplying power to one side of the switches, and then the signals are then going out on the green, and in this instance also on the red. They're controlling the little warning indicator lights that we've got on the side. Up the top here we've got our range of inputs. So in this instance we've got 8 inputs, eyes number 1 through to eyes number 8. You'll quite often find that on most PLC setups, including some of the more advanced Siemens units, they will nearly always start with an I0, which can be a bit confusing at first, but as you will learn, there's lots of different language and terminology surrounding PLCs, but they're all there for a fairly good reason, and we will cover a few of them as we go forward. The power is supplied here by a little power supply that provides a 24 volt DC output. So we have single phase mains coming in on one side, on the brown and the blue lines coming in here, and then we're able to supply both a positive 24 volt and a negative output going into the PLC. One of the peculiarities with the Siemens units is live is always labelled with an L+, the negative is always labelled with an M, which when you first see it is a little bit confusing. But that is our basic PLC system that we can then get into and program quite easily. Under here we have an input for an Ethernet cable, which gives us direct connectability to our PC. These particular units will also take a little memory card in this slot here, so it is possible to walk around a facility with a single change that's going to go into all of your PLC units on a simple memory card and just install it straight in and run it from there. So a very sophisticated little unit for less than £200, which makes these almost practical for use for automation within the home. And there's certainly quite a lot that you can do in terms of controlling things around your house. With one of these you'll be quite surprised. These would be ideal, for example, for an automatic garage door opening system with lots of safety backups and perhaps some remote control as well. So as a project start, these are probably the best way to go. Okay, so quick tour of the demo board that I've got set up here. Over here we've got a set of indicator lights. So currently this top light here, top left, that will come on to tell me that the system is live and it's supplying the 24 volts to the rest of the circuit. So that's just our safety light, our indicator light. These lights are wired in such a way so that when these outputs become live, these lights will come on. And that's quite useful because it allows us to get a feel for what's going on within the system. Generally you wouldn't find that in most industrial setups, but for testing and learning, having lights on can be really beneficial. I've got a selection of inputs, so in this instance I've got 6 inputs wired in, going through eyes 1 through to 6, and they are just simple locking switches to turn the input signal on or off. Over here I've got a set of industrial relays, exactly the kind of thing that you will find in most of your setups that you're going to be building. There are loads of different styles of relays. I personally like these little finder relays because for fault finding they have a little mechanical override, so if you press this little button here it mechanically pushes the contacts over. You actually might just be able to make out a little red indicator coming up in this little box here, which means that you can just test to make sure everything's working just by pressing those little buttons on the top. Which again makes, when you're trialing stuff, doing experimental stuff and starting to learn, it makes it very much easier. Now these relays are switching power, which in this instance is supplied by this little 3-volt battery pack. I wanted to keep it separate from the 24 volts. This 24 volts we've got supplied here by the power supply is purely your control voltage. So we use that for switching relays on and off. We use that to supply the current to run through the switches and go back to the PLC. We don't want it to do any heavy lifting. In most instances, what your 24 volt supply will be doing is it will be energizing relays and contactors, which will be switching much heavier loads, 415 volt 3-phase, single phase, various other high load applications. So we need some separation, and you need to understand there's separation. So although this is only 3 volts, you can quite easily think of this as being 230 volts, 415 volts, doesn't matter. Just be aware that it's separate, and that's worthwhile putting something in as a bit of separation. I've built in some little buzz bars. Now these aren't particularly sophisticated, I've just used some standard electrician's chocolate block, and what we've got here is I've got 3 positive outlet terminals and 3 negative terminals. So all we've done is we've got 1 wire coming from our power supply, and it's trailing across to the top of our buzz bar, and then I've got a loop going into the next one and a loop going into the next one. So when this one here becomes live, all of these 3 terminals and all of these open terminals underneath are also live. So that means I can distribute a lot more of that 24 volt very easily, rather than trying to cram lots of wires into the tiny little hole that we've got here. And buzz bars are very common in most electrical control cabinets as a means of accessing the control and supply voltages that you're going to need. It's important that the PLC sees a perfect circle, as with all circuits. So in order for these switches to work, we have to supply them with 24 volts that comes from the power supply and then links into the PLC. So we've got it coming through here, it goes down to the switches, from the switches it goes back up and into the individual inputs. Anything else we put into the circuit also requires a negative. We need to pick up on the negative that we've got in this little buzz bar, again just done with a couple of loops. So I've got 3 terminals. Got another little buzz bar here for our 3 volt external supply, and although it looks complicated and there's lots of wires going through there, lots of different colours, if you do it systematically, take your time, you'll soon work out where everything goes and you'll be able to build these fairly quickly. So I've opened the Logo program, Logo Soft Comfort as it's called. Started off with a new project, and I've gone here into my network project, and there we can see our PC sitting there ready and waiting. So I'm going to move across to the Go Online and click on that, and we can see it starting to scan, and yes, it's picked up that there is a PLC on the network. We can go on the settings for that PLC, and we can give it a name. So let's call it Logo. We have its IP address, we have its subnet mask and its default gateway settings all already loaded in, and generally the software will sort that out for you. If it comes up asking if you want to change something to allow for communications, the best option is to say yes. Now I know that there's already some programs built onto there. One of the best ways to make a firm connection is to actually upload any data that might be on your PLC, and even if it's a fresh new one, it's worth doing. It's also really good practice to get into. So if you are on the plant floor and you've been tasked with making a minor change to some of the programming on one of the PLCs, the first thing that you should do is download any programming data that might already be on the PLC before you start to make your modifications. if you don't do that and you get something wrong, you then don't have that original to fall back on. So it's always worth to just go on to the upload. So here we have a little tiny representation of the PLC and an upwards pointing arrow, and as you see it goes from the logo to the PC. So we click on that and it's connected. Device is in stop mode, change to run. Well, in this instance we don't want to do that, so we'll say no. And it's picked up any software that might already be in existence, and it's down on this bottom diagram editor. You'll notice now that this has gone firm. It's got a little tick on here that says yes, I know what it is, and it's actually put a not particularly accurate visual representation of what the PLC it's communicating with is. It's also possible to add new devices over here, but it's often best to just let the software itself look what's on the network and make decisions for you, as long as you just make sure you know exactly what it is you're dealing with. So what we're going to do, we'll get rid of everything that we've already got on there, so we've got a nice clean slate. We can forget this network view for now because we don't need to worry about it, and there's a little tiny minimize arrow here, which is a bit fiddly, that gets rid of all that. It's still there, but it's hidden.